Hello, welcome to this channel. My name is Enoch. Today we will continue our series on networking. I'll be looking at DNS. DNS stands for Domain Name System. It is a protocol that operates at the 7th layer of the OSI model. It simply maps domain name to an IP address. Every resource on the internet, whether it's a website or an email server or a file sharing service, is identified by an IP address. However, IP addresses are not human friendly. Human prefers names over numeric IP addresses, and DNS bridges this gap by associating IP address with human readable names called domain names. DNS is also important due to dynamic IPs. IP addresses can change due to server relocation or load balancing, where we are using multiple IPs for the same domain. And DNS allows this without affecting users. All we just have to do is to go and edit our domain with the new IP, address that we have. DNS also simplifies the management and accessing of network resources because we'll only be dealing with the user-friendly domain name rather than the IP address. Features of DNS. There are some features or concepts that we need to understand for us to be able to really comprehend DNS very well. And one is that domain names are hierarchical. They consist of multiple labels separated by dot. And the first one is the root domain. A root domain is an hidden period or hidden dot that is in front of every domain name. And the next one is a top level domain, which is the last part of every domain name like .com, .org, .net, and so on and so forth. And we also have the second level domain, which is to the immediate left of the top level domain, as we have it in example.com. The example part of it is a second level domain. We also have the subdomain, which is to the immediate left of the second level domain. For example, in www.example.com, the www part of it is a subdomain. Also, as we have it in blog.example.com, the blog part is a subdomain. These subdomains are used to create an alias to a domain. Another concept that we need to also look at to understand DNS very well is the DNS servers. In DNS hierarchy, there are three different servers that we need to understand. One is the root server. The root server is the root or the top of the DNS hierarchy. It is like a directory that directs queries to the appropriate top level domain server. It is a starting point for resolving domain names into IP addresses. And there are 13 sets of these root servers strategically located around the world. We also have the top level domain server, which keep record for top level domains, such as .com, .org, .net, and so on and so forth. We also have the authoritative server. The authoritative server contains the original mapping for domain names to IP address. It stores DNS record for specific domains and provide answers about them, during queries. We also have the recursive resolver. It's not specifically part of the DNS server hierarchy. It's just the intermediary that queries all the DNS servers during DNS resolution to IP address. And there is also the DNS record, and DNS relies on various types of records stored in its database to resolve domain names to IP address, and each record serves a specific purpose. And one is the A record or the address record. A record simply is used to map domain names to an IP version 4 address. It is used to map a domain or a subdomain to an IP version 4 address. We also have the quad A record, which is used to map a domain or a subdomain to an IP version 6 address. We also have the canonical name record, which is a CNAME record, which is used to create an alias, to another domain. It is used to map a domain or subdomain to another domain or subdomain. We also have the MS record, which is the mail exchanger record. This record is used for email. It directs email to the correct mail server for that domain. We also have the NS record, which is the name server record. It specifies the authoritative name server for a domain. We also have the TST record, which is the test record, which provides arbitrary test data. For example, when you are verifying a domain ownership. And we also have the SOA record, which is the start of authority record. It contains administrative details, such as primary name server and the zone's serial number. And how does DNS works? DNS operates in a client-server mode and involves multiple steps to resolve a domain name into an IP address. When you type a domain name like www.yahoo.com into your browser, or you just type yahoo.com, the browser or the operating system first check its local cache for the IP address. If it's available, then the process ends there. If not cached locally, then the request is sent to a recursive resolver, which is usually your internet service provider. If the recursive resolver has the IP address cached locally, then it returns it immediately. And if it doesn't, then it queries the root server. The root server does not know the IP address but has the record of all the top level domain servers. It just points the resolver to the appropriate one. And the resolver then queries the top level domain server, which also does not have the answer. It does not have the IP address, but provide the resolver with the address of the authoritative server for that domain. The resolver then queries the authoritative server, which now responds with the IP address, of the domain. So the resolver cached the IP address and also sent the IP address back to the browser, which then uses it to connect to the web server. So this video is just a preamble, for the practical DNS part that we will see when we get to cloud infrastructure provider like AWS and Azure, where we'll be looking at concepts like load balancing and routing policies. And we will look at how some of these concepts are used to route traffic appropriately. So thank you for watching this video. I will see you in the next video.